Hey, hello everyone. So today we are going to solve this LeetCode problem, which is combination sum. This is part of the dynamic programming algorithm, and it follows the backtracking technique. So here is something which is different from other knapsack problem. This is something which follows backtracking method. Here we uh, we'll first go to the problem where it says that given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates with the chosen number sum to target. So all unique combinations of the elements in the candidates array where we can sum them to form the target. Okay, but the trick part is the same number may be chosen from candidates at unlimited number of times. So this is a tricky part of this question where the same number can be chosen unlimited number of times in order to form the target sum from the combination array. So two combinations are unique if the frequency of at least one of the chosen numbers is different. Okay, the test cases are generated such that a number of unique combinations that sum of the target is less than 150 combinations for the input given. Alright, so here is the candidates array and here's the targets. So the output will be 2, 2, 3 and 7. Alright. So 2 and 3 are candidates where 2 plus 2 plus 3 is 7. Note that 2 can be used multiple times and 7 is a candidate, so 7 is equal to 7. There are only two combinations from the given candidates array. So here we follow the backtracking method where we will visualize a decision tree where it starts from 2 and then we can we have options to choose 2 and we have option to choose 3, and if we choose 2 we have options to choose 2 again since we can have duplicate. So it's a in this way we will keep on choosing and until this sum which is formed is basically within the target number, and if the sum exceeds the target number we will just backtrack the last chosen value and then we will retrack the other path of the decision tree. So here the code look like something. We have list of nested list of returns. So we have list of teacher result equal to new list. All right. So we have this result as new array list, and here after this we will um, call a backtrack function uh, which will contain this result, which will contain this result and one array list which will be used as temporary list, and it will contain candidates, it will contain target, and it will contain 0 which will be the start, and then we will return this result from here. Alright, so here we have this inside this method, and now we will have this backtrack method being defined which will be called recursively, so which contains this list of integer result, and it contains list of integer which will be temp list. So this will be list of integer which will be result is global variable. Okay, variable the same pass from here, list of templates. Then here that is candidates. It will be integer type defined, and here we'll be having target, and here we'll be having int start. So this will be of void type, and okay, what is wrong here? Defining structure. Alright, it is resolved. Anyways, so here is this method being defined, and we will be just calling it recursively, and we have to also make sure that the conditions are backtracked, and when the sum is exceeding, we have to remove the last element of the considered array, and just we need to choose the other different element from the candidates array. So we should have a base condition which will basically check if the base conditions saved with that if the target, which is basically the remaining, and base condition says if the remain is less than 0, then we have to return, and else if um, remain is equal to 0, then we have to just add into the result array new array list, new array list, and here we will go with the temp list. And alright, so this will happen with this two condition, and then there will be an else condition which will basically calling this backtrack method with its values such as result and temp list and candidates and remain, which will be remain minus temp list of we have to iterate. There will be for loop which will start with int I equal to start, I is less than candidates dot length I plus plus. This recursive function will be called inside this for loop, which is the trickiest part of this problem, and um, basically this is the only way that this makes this problem unique, is that we have to consider this condition, which is the same number may be chosen from the candidates unlimited number of time. The only way is to call this recursively and have different level of recursion, and inside that level of recursion we will have this iteration among the candidate array to make sure at each level whether we are able to form with the combination that desired sum. So basically these are the two base conditions for remain less than 0, remain equal to 0. If it happens, it just add into the result list and it iterates in the else condition, and inside this for loop basically it just add it into the templist dot add, and it will be candidates of I, and whatever fails basically inside this for loop it will keep on moving, and if this backtracking fails it will just come to the bottom, and it will just remove from the temp list dot remove uh, temp list dot size -1, the last element being added, since it is causing the sum to exceed the target sum, so we are removing, and once we are removing that, the for loop last iteration is completed, and then the next iteration will start at that particular level of recursive call. So this is result, this is template, this is candidate, this is remain minus template of not templates, this is remain minus candidates dates of I comma start, which is basically I. Alright, so this is the backtrack being called, and let's run this problem solution. So compile error, from where does this has entered? Anyways, alright, it is accepted. Okay, so the thing was that we are basically calling, considering this condition. If I take this 2 3 6 7, we are just calling this in a decisive tree where first 2 is called, and then we check with 2 2, and again we check with 2 comma 2 comma 2, which is again less than 7. Then we check with 2 comma 2 comma 2 2, which is 8, and the condition base condition check passes, which is remain is less than 0. It returns. When it returns, so this is basically happening at 1 2 3 4 level 4. It is returning at this line, and here it is just removing the last element, and after removal the value becomes 2 comma 2 comma 2. This is the new array, and after this, now at level 4 this for loop starts iterating from start, from next I plus plus. So after this 2 2 2, it will add 3, then it will add 6, then it will add 7, and it will keep on adding and keep on calling backtrack, and it will keep on checking these two conditions. And when all these conditions are fulfilled, and we roll back to the level 3. And in level 3, when we come to the this all happened at level 4, we come to level 3. When level 3, uh, again the code enters into the last statement, which was remaining after the recursive call, and it removes the uh, last value from this, keeps on continuing until we reach level 3. It removes the last value, and now it becomes 2 comma 2, and then the for loop iterates again at from the level 3 recursive call at I plus plus, which will I will be 1, and which the value will be 3. It will just add 2 comma 2 comma 3, and the sum will eventually be equal to 7, and then it will add in the result list. This is how it follows this algorithm. And so it was a tricky part, and it is one of the uh, different unique way of solving the dynamic programming using backtracking other than an abstract problem. So see you in the next problem. Thank you.